My name is Keith Rucker, and today I'm back out at the Georgia Museum of Agriculture, and again we are working on the restoration of the J.A. Vance Planer matcher. And in the last two videos we've done a couple of things, a series where I've shown how I have replaced a broken tooth on this gear here, and we're still finishing up getting this gear ready to go back on the machine. Before we could do so, now that the repair has been done, we needed to do a couple things. This is an idler gear, so it basically is just going to be free turning on a shaft. It's not keyed to anything at all. It's just a reduction gear where a small pulley engages the big pulley, and then this small pulley engages another big pulley, and it reduces the speed of the feed rollers on this particular machine. So this one is just free turning. It rotates on this shaft right here, and as we showed in the previous videos, this shaft was very rusted when we took it off. Very pitted, and basically we're going to have to replace this shaft is the bottom line. It is just pitted beyond use. Also, in the gear, there were two bronze bushings, one pressed in on each side, and these bronze bushings were worn excessively. In fact, there was about 200 thousandths of play where they had been rotating, probably because these bushings had been rotating on this shaft here that was so rusted and pitted that it was just basically like sandpaper cutting on it. So we're going to have to make two new bushings and press those back in. We've already pressed the old bushings out, and these are garbage, and we'll be making new ones going here. So first step today will be to make the bushings, and then we'll make a new shaft here to fit this. And the shaft is actually quite interesting. It was pressed in, but it goes down 3 different steps. So there's 2 different press fits in here. There's 2 shoulders inside there. I don't know, that looks like over-engineering to me. I'm not sure exactly why it's done that way, but this is what we've got to make to go back in there. We are set up over here now, and before I get started turning the bronze bushings, I need to make sure I got all my measurements right. So as I usually like to do, I like to work off of a plan or a drawing or a sketch, and this is usually just something that I'll throw together, just a rough drawing, so that I have something to reference back to when I'm making something like this. So first thing that I want to do is determine what the inside diameter of the bushing needs to be, and we know it's going to go on this shaft. This is the original one. Of course, this one is very badly pitted, but I've come over here and measured it, and I found an area on here that is, you know, fairly true still has machine marks on it, and I've measured around it, and just using the dial calipers, it's ranging, as I rotate it, anywhere from about 1.245 to 1.255. So we're going to call it 1.250, which is 1.25 inch, nominal size, and I'm sure that's what the original was 1.25 inches. So we're going to make that inside diameter 1.250. When we've turned this part, we'll actually make it exactly 1.250. So for the bushings, I want that to be just a little bit oversized because we want it to rotate on there. So I'm going to make it 3 or 4 thousandths larger when we bore out the inside of those bushings. The next thing we need to know is the outside diameter of the bushings that we need to turn. And to do that, I'm just going to take some measurements. This is just a telescoping gauge, or a snap gauge, some people call it. It's spring-loaded so that when you open it up, it expands. And the faces on these have just an ever so slight radius to them. And you use this for going down inside of a hole. So I will just close it up. I'll put it down inside my bore. I will then release it. It will expand out. And I'm going to tilt it over ever so slightly. It doesn't have to be a lot, but just a little bit so it's not straight up and down. And I will tighten it up by tightening up that little screw on the end. Now it's not coming in and out. I go down in here, and what I'll do is I'll just pull this over, and by doing that, again, because these ends have a little radius on them, that's going to measure the exact thickness there. And I'm going to just right now measure it with the dial calipers, and it's measuring 1.690, and I'm going to do this multiple times. I started with the dial calipers just to get a quick and dirty rough measurement on it, and I'm just going to look and see. But because this is a critical measurement, My dial calipers are great. I love them. I use them a lot. But when I have a really critical measurements, when I start getting down to tolerances, you know, in a thousandth inch or so, I really like to use a micrometer instead. So I'm going to double check and verify those measurements that I've made. And I've actually already measured this several times on both sides. I'm taking the shortcut version here. And I come in here and measure this with the micrometer. And we are right at 1.690. So that's my calipers in this case are measuring pretty accurately. Because this is going to be a press fit for the bushings, I do want to turn them just ever so slightly on the large sides. And when I make that final cut on this, I'm going to shoot to make that between a 1/2,000th and 1,000th of an inch larger in diameter, so that I will have a good tight press fit, interference fit when that goes in there. And anyway, we'll show you how we do that when we get to that later on. But so now I've got some measurements here. I know that my outside diameter, it needs to be 1.690. I'm going to put a plus beside it because I want it to be just a little bit on the large side. I know that my inside diameter is 1.250, and we're pretty much ready to start making this bushing. We have the bronze bushing blank now. This is just a piece of bushing stock. It's oversized on the outside diameter. It actually has already got a hole in it, but this has got to be trued up. It's not a turned hole or a finished hole. So we got this set up. I got the length sticking out for the total length that I need, the bushings. I'm actually going to make two, but I'll turn them as one and part them off into two separate bushings. I've got this set up in my chuck on the lathe. Some of you may notice this is a 4-jaw chuck, but I will point out that this is actually a 4-jaw scroll chuck. So the 4 jaws do move in and out together like a 3-jaw chuck would. I bought this chuck to use for turning square stock, and I needed to have, instead of a 3-jaw chuck won't chuck up on square stock. And I like this chuck. It's a smaller chuck. This is a fairly large lathe that I'm using. It's a Lodge & Shipley Model X 16-inch lathe. And when you're turning smaller stuff, the great big 3-jaw chuck that we have on this lathe is just sometimes cumbersome to use. And this is a smaller chuck I really like using for smaller stuff, even though it's 4 jaws. But because it's a scroll chuck, it works like a 3-jaw chuck. So anyway, we've got this set up. It's sticking out. And I also have my boring bar here. First step I'm going to do is bore the inside diameter. Now I have the length of depth here set so that it's just a little deeper than I need to go. That way I know that if I run this pretty much all the way into just right before it starts hitting, I know that I've gone deep enough, but I don't want this to be any longer than absolutely necessary because the longer this is, the more flex you're going to have in it, and the more chances you have for a hole that's not exactly true. So anytime I'm boring with a boring bar, I try to set it to just no longer than I absolutely have to sticking out. Okay, the next thing we need to do is set the tool post up square with the part that I'm turning. So to do that, I just brought it in here with the piece sticking out, and I bring it up and I just set it on here so that this back edge was right up flush to the part that I'm turning. And that's just a quick and easy way to get your tool post set square. So we now have this pretty much ready to go. I'm going to drop my boring bar into place. That's running low, so I need to raise this up. We want that boring bar cutting just right on or just barely below center. So we'll come in here and I'm just going to eyeball that, but that's pretty good right there. So this is ready to go. Another thing I'll do with the boring bar before I actually start boring is, with the machine turned off, I'm going to just run it the whole depth in and make sure that I'm not getting any, that it's going to actually fit all the way in there. There's not any obstacles or anything. You don't want any surprises on that first pass through. And I'm going to turn the lathe on and actually do that with the lathe turning, but not making a cut before we get started. And we'll put this in here. We'll make a couple of cuts until we get it cleaned up and true on the inside. I'll come in, take a measurement, see where we're at, and then we'll go from there and get that inside diameter bored out where we want it. And we're going to make about a 20 thousandths cut. It could be 40 thousandths total. And that looks like it's truing up in there. Well, maybe not quite. It's close. We'll run that down to depth. Okay, now we're going to check the inside diameter. Again with the snap gauge. I had to grab a different one. This one on the other one was a little too large. So same process. We'll pull that out, and I'm just going to check this with the dial calipers to get a rough idea of where we are. And we are on 1.201, so we've got about 50 thousandths of an inch to cut on the inside to make this where we want to be. So I'm going to make about a 40 thousandths cut, and instead of trying to cut it all on one pass, that's 40 thousandths or 20 thousandths cut, 40 thousandths total. On lathe, you're removing on both sides, so you double that number. At least that's how this gauge works on this lathe. So we'll cut 40 thousandths total, and check that measurement again, and then make a final pass. Now that we have the inside diameter all bored out, I've got just a regular turning tool on the lathe here, and we're going to go ahead and turn this outside diameter down to the correct dimension, which is going to be 1.691 is what we're shooting for. The nominal size of this is 2 inches, give or take a little bit. It's just a rough finish extruded piece here, so we're going to have to take about a little over 200 thousandths total off of this to get it down. And the final step here is we'll actually part these pieces off. I'm going to come in here and use the old bushings as a guide as to how long to cut them. This isn't super critical. There's actually a gap between these two bushings inside the pulley that will serve as a place for the grease to go or the oil to go. So it's not super critical. And from there, I'll just come in here and we'll part this off. I have the bushings now made, and we're getting ready to press these bushings actually into the gear. And to do that, we're going to use the hydraulic press. But just a little quick, easy trick when pressing in a press fit like this. You can actually use heat to your advantage. So what I'm going to do is I did two things. Number one, I took the bushings and I actually put the bushings in the freezer back there in the office, and I've had them sitting in there for a while to get them good and cold. And what that will do, well, that will actually will shrink the outside diameter of that just ever so slightly. Remember, we've only got about 1/1000th of an inch of interference in here, which is a lot of interference when you're trying to press this together. But if I can cause that bushing to just shrink ever so slightly, it's going to make it go in easier. At the same time, I'm going to take my torch and I'm going to heat this up. We're not going to get it red hot. but we are going to get it warm enough that you can't really touch it without feeling some heat on it. So we're going to just warm it up, and again, that heat will cause this metal to expand just again ever so slightly. And when we come over here with the bushing, hopefully we can just press it right in without much pressure at all. And then when it cools down, it will actually shrink up around that and make a very nice tight fit. So we'll get started on heating this up. Very nice. Now we're going to repeat this process and do the back side of the gear. Very good. We're going to let this cool off, and our bushings are in. Here is the finished press bushing, all in there. You notice these two holes on the side. This was something that the previous person that did this did, is he actually drilled and tapped two small holes there to hold that bushing in place. I really don't think that's necessary. I'm not going to repeat that. In fact, I really don't even like that fix at all. But I have used that technique before when I was worried about something sliding apart to fix it in place. But with this, with the movement going around in a circle, I just don't see those bushings coming out. Plus, they're captured between two end pieces, so they really can't move out anyway. So I'm not going to worry with going back and doing that. We're ready to start turning this piece now, the arbor. I've got a piece of stock mounted up in the lathe back here that we'll be turning that out of. It's a little bit larger than this largest diameter, and we'll get going on it. I've got a little sketch up drawing that I did of this, so I'll have some dimensions to work off while I'm going. We'll get started. We'll face the end and start turning it down. It's reading exactly needing 20 thousandths right now, so we're at 1 inch 270 thousandths. We're going to measure that again after it cools down. Exactly 1 inch. All right, I came in here and threaded this at 1/8 or 1 inch 8 threads per inch. We did that off camera. I had a fella in the shop that was wanting to see how to do threading, and it just wasn't feasible for me to work with him and run the camera at the same time. But we'll show that on the other side. We got a thread to cut over there, and also I've got a couple of videos up that talk about threading a little bit more in detail if you're interested in that. But anyway, we've got our nut here, and that's threading on there just right. It's yeah, I mean, it's just A little bit tight right there, but that's the way I want it. Not too tight that I can't turn it with my hands. So anyway, we've also let this cool down, and we can touch this now with no problem. So I'm going to get another measurement. And if we remember, this was 1270 earlier, and now we're at 1267. So it shrunk 3/1000ths of an inch. So that's exactly why I wanted to make sure that we let that cool down, because just that little bit of, just the heat that was in that part caused it to measure 3/1000ths over size. So now with it cool, I can come in here and get that down to a pretty tight tolerance. If I had gone ahead and cut it while it was hot, it would have shrunk down 3/1000ths between now and whenever we were, after it cooled down. So let's go ahead and cut that final dimension. We have the arbor on this side of this piece turned out now, and I want to, before I take it out of the chuck, we want to do a test fit on the actual gear with the new bronze bushings in it to make sure everything's going to fit right. So here we go. We'll do this on the lathe. We mess our setup up, and yeah, that looks very good. We just got about 2/1000ths of an inch, or maybe even 1/1000th and a half, it looks like, between the diameter of the shaft versus the inside diameter of the bushing. So this is going to make a very nice fit, very smooth running gear, and that should give us many more years of service. So we'll pull this off now. We're going to flip everything around, and we'll turn the other side. Because this is just a shaft sticking out of the side of the machine, I'm not going to worry about trying to turn this between centers and get it set up just perfect, because it's just not that critical that the turn diameters on opposite sides be exactly in line with one another. So we're just going to go ahead and turn that out and just put it in the chuck. We'll probably have a couple thousandths to run out, but again, that's just not going to be important in this application. We have turned the part around in the chuck, and now we're going to start working on the other side. This is the side that gets pressed down in there. It has basically 3 steps that we'll be turning in there. The first step is going to be a real critical measurement. This will be the press fit. The second step, it looks like is not really pressed in. It's just loosely fitting into that. And then the bottom end down here will be turned down to 1 inch, and we'll put a 1-inch 8-inch thread on it, just like we do on the other side. So we'll get started turning this. Okay, we're reading 2.025 on this, which is about 25/1000ths over the dimension that we need. Again, you know, we got a lot of heat in that part, so I'm going to let that, leave it there, and we'll come back after this is cooled down and make that final cut. But right now I'm going to just continue roughing this part out, and like I said, we'll come in and do the final cuts on all these after it's cooled down some. Alright, we're down to about 20 thousandths or less cuts on all three of those diameters now. So we're just going to let this cool off in the lathe for a little while until it's cool enough you can come in and touch with your hand, and then we'll finish making those final passes on it. Alright, we have this turned down to 1 inch, and we need to thread this 8 threads per inch up to about where I have my tool set right now. It's going to be my bottom end. I've got the lathe set up for turning 8 threads per inch. So we're going to go ahead and start cutting this. I'm not going to go into a lot of detail on how I cut threads. I've actually got another video out there, I think it's titled Making a Square Head Bolt, that goes into a little more detail on cutting threads on lathe. So if you're interested in that, I'd encourage you to go back and look at that video, but we're just going to go ahead and get this one done. So we'll start out by making a light pass and double checking with our thread gauge to make sure we're cutting 8 threads per inch, and then we'll go to town cutting the threads. Right now I'm just marking the bottom end where I want to stop at. I'm going to come up to the front edge, and I'm going to just chamfer, put in a good chamfer on that front edge using the leading edge of my thread tool. Okay, now I'm going to come in here and barely touch off. Right there. I'm going to set the dial on my cross side to 0. And I'm also going to slow my lathe down a little bit. I don't like cutting threads quite that fast. And we'll make a test pass here, just barely touching to check to make sure we are cutting 8 threads per inch. Using my thread gauge, I can see the marks on there, and I'm just making sure. And we are cutting 8 threads per inch. I'll pull this out, come over, go back to 0 on my dial, and I'll just feed in using the cross slide, which is set to 29.5 degrees. Almost half of the 60-degree angle that's in the thread. I'm making about a 5/1000th cut here, waiting on my thread dial to come around to engage and go. Those are going to follow right where we went a while ago, and continue to do that on each pass as we just go a little bit deeper. And continue this process until we get the job done. I like that. That's perfect. All right, there's the original part back here. Of course, again, you can see the pitting on the shaft, and here's the new part that we've made. And this is ready to go press into the piece, and we'll have this part knocked out and the gear ready to put back on the machine. I have the flange over here in the press now that this will go into. So this piece is going to come right in here and just drop right down in here. Right now, I've got about 1/1000th of an inch of interference, where these are about 1/1000th of an inch larger than the holes that are bored in this flange. So again, I've got it on the press, and my plan is I'm going to come in here, I'm going to heat this up with the torch. Not red hot, but hot enough that you can't touch it. And with the hope that that's going to expand that diameter out. And with any luck, when I come over here, this shaft is just going to drop right down in there. And then when it cools, it will shrink up. But I have it over here on the press, so if that doesn't happen, I can still press it on into place. I could probably cold press this into place, but again, I like to use heat as my advantage, in these situations. So we're going to try to let the heat do the work and then shrink it on there. But if we can't get quite big enough, we should be able to come in here and press it on and get it home that way. So let's get going here with some heat. All right, very good. That went down almost all the way down. There was maybe a 1/16th to an 1/8 of an inch left at the bottom of that press that we just had to press it in. So we're going to let this cool down, and it should shrink right on there, and this part is done.